In this video, I'm going to show you how I put together this 55-foot greenhouse in under a month without any help. This is a long video, so you can use this index to remember where you left off if you plan on watching it over the course of several days. The information shown here is good for any of the round-framed galvanized greenhouse kits. There is a link to the company that supplied this one in the description. Also included in this video are raised beds and workbenches, as well as this heated propagation table to jumpstart your growing season. Okay, let's start this adventure right from the very beginning. Seriously, right from the beginning. I learned a lot of things on this adventure, so hopefully this video will show you a few things that will help you save time and get your greenhouse installed. Before you even start on site prep, you have to consider logistics. Your greenhouse kit is going to show up on a skid. You're going to need more than a pickup truck to get it home, and a few hours to unload it if you're doing it by yourself. I rented this cube van, drove it to the site where the greenhouse showed up, and they loaded it on the back with a forklift. All of the individual boxes are wrapped in plastic, so it's going to take some time to unwrap it and get them off the truck. Usually when you rent a cube van like this, you can have it for the full day, so take your time and make sure everything's there. Keep your camera handy as well when you're unwrapping everything. If there's any signs of damage from the forklift, take a photo so you can email it to the company that supplied your kit. Look at the packing list and do a quick count of all the boxes just to make sure they're all there. It's spring out here, so it's mucky clay and snow. I brought the truck up as far as I could and then had to use a wheelbarrow to get everything over to the site. Since there's only a few months of summer out here in the north, we had to start early to get everything done by the end of the year. Good thing I have that rental truck for the full day. Yeah, this is quite the slog. Something to consider if you need to do ground prep and the ground's still frozen. This hard clay soil makes it even worse. After a long cold winter, it's nice to get some exercise outdoors, so keep on trucking. If your boxes are labeled, check them off on the packing list as you move things out of the truck, just so you know you have all the components. It also helps to arrange things in some type of logical order and try to have the labels facing outward so you can ID the parts that you need to use. The heaviest box was maybe 30 pounds, so it's not a big deal for one person to move everything out alone. Each box had a part number clearly visible on the outside, and that made checking them off from the packing list really easy. The largest boxes will be 4 foot by 8 foot. They will have the polycarbonate sheets, and since they're not that heavy, watch out if you're moving everything around in a wind, because these boxes can get away from you quite easily. Greenhouse kits usually have 3 sections: a front section, a rear section, and the center section. The number of center sections you add to your kit determines the overall length of your greenhouse, so you can build a greenhouse to just about any length. The real limiting factor is your ground preparation. It's pretty hard to level a 100-foot long section to build a greenhouse, so you might want to consider 2 units instead of 1 if your ground isn't completely flat. So here is what we're going to build. This greenhouse is called SunGrow, and it's from the company Planta. This photo says the greenhouse is 10 feet wide, 8 feet high, and only 6.5 feet long. This is the length of a center section. We have 7 of these, as well as the front and rear section, which is why our final greenhouse is 55 feet long. Okay, all the parts are unloaded and nothing's missing, so let's start on the site prep. You will need a few basic tools to mark out your site, starting with a very long measuring tape, a standard measuring tape, and then some marking flags that you can stick into the ground. These little marking flags are super useful, so we keep a lot of them on hand at the farm here. Here is our proposed greenhouse site, marked and ready for the excavator to come and remove the top layer. In the next few steps, I will show you how you can mark your site, But first, let's take a look at this site and discuss why it was chosen. The most obvious thing is to try to choose flat ground so you're not reworking the land. Out here there isn't a lot of flat ground, although this section looks pretty good. All of our yard also has a slight downward slope, which actually works in our favor when it comes to drainage. The tall grass in the background is a crop field, and these small bushes are actually established fruit trees. Luckily, there was enough room between everything to get the greenhouse to fit. If you use equipment like a large mower or a tractor, consider the clearance you're going to need between your greenhouse and whatever's next to it. Also in the winter, the greenhouse is going to shed quite a bit of snow, and for northern climates, you may want to use your snowblower to remove that pile of snow that's going to shed from the greenhouse, so consider all of this when choosing your site. For marking out a site, a couple lengths of rebar or steel rod with washers or chain links welded to the end make it easy to run a string between all four corners and pull it tight. With this installation, I'm going to be ripping up the top layer of sod and then bringing in 4 inches of gravel to pack it down as hard as possible. So I've measured a total width of 12 feet, which gives a foot of extra clearance on each side of the greenhouse, which is 10 feet wide. Those two 8-foot-long pieces of plywood are bolted together at exactly 90 degrees, making a huge square, which makes aligning the frame much easier. If you look from the top and compare your string against the edge of the board, you can tell if both are in perfect alignment. Do this same thing on both corners, and you will be guaranteed to have a good 90-degree angle between the string. Check both 90-degree angles at the shorter end, and then move along the link to the other end and try to get them as close as you can. At that point, you'll have a fairly decent rectangle. To check your final measurements, take your long tape measure and run it diagonally between the two farthest posts. Basically, you will be drawing an X through your rectangle. This is a great way to determine if your rectangle is perfect, because both legs of the X will be exactly the same length if it is. If both legs of the X are not the same, what you have created is called a parallelogram, and that won't make for a good greenhouse build. The good news is that if your X isn't exactly the same, you only have to move 2 posts. So the 2 posts on your initial measurement can be considered permanent. I will admit I'm showing you my measurements after I moved the posts at least 3 or 4 times here. Try to get the tape as tight and straight as possible with one end securely fastened to the first post. You might have to lift the tape up and down to get it to clear the grass, but just make sure that it's perfectly straight from one end to the other. Okay, it looks like I have 55 feet and 7 inches here. At this angle, you can really see the slope of the yard, which is good because all water will drain downhill, and there is a large hill just beyond that little shed out back. Okay, so now we take our long tape measure and check the distance between the other 2 diagonal posts. This simple diagonal measuring method works on both squares and rectangles. It's a great way to check your work when you're putting up walls, putting up a fence, or just trying to excavate some ground. The longer the greenhouse, the more this measurement counts. Even more so if you're going to build a wall and put your greenhouse on top of it like I am here. Hey, what's going on here? Looks like I'm about an inch too long. Does that really matter? It matters to me. There's the problem. Tape measure's stuck on a weed out there. This is why you want to cut the lawn before you take these measurements. So there it is, 55 feet and 7 inches again. And yes, that was after moving the posts a couple of times to get it right. Okay, now the site's marked and an excavator can come in and rip up the top layer of sod. I'm not afraid to use a hand shovel, but this is 672 square feet and I'm not doing it by hand. If you live out in the country, it's always good to get to know people. Advertise your skills, do some bartering, find out who's got what type of machinery, and work together. Well, I certainly don't have one of these sitting around here, and I was lucky enough to meet someone that lived close enough that they could just drive right on over. Having rubber tires is great as well because tracked vehicles completely shred your yard. I explained to the operator that I wanted the first 4 inches completely torn up, but to keep the natural slope of the yard so that any water would drain down the hill. No problem. I've seen this guy work and he's got skills. It's now been 2 months since I unloaded the greenhouse kit, but I really had to wait for the ground to become more solid in order to get a machine like this into the yard. Digging in wet clay is impossible for just about any machine, so let's see what we're up against. Oh yeah, that is dried out nice. 2 months ago, the clay would have been sticking to the bucket, and the wheels of the excavator would have been sinking right into the ground. I was hoping to just sit back and let all this magic happen, but then I realized, where's all that dirt gonna go? The original plan was to truck the dirt using the larger bucket down the hill and dump it off, but that would greatly extend the amount of time it would take to do this job. Plus, it might leave ruts in the yard. Even though the ground's hard, this machine is really heavy. There's always some little detail that you forget when you're planning a job this size, especially when it's your first time. Looks like the job's going very well. That ground is super hard, so it's a perfect base to fill with gravel and then pack it down. That's sure a lot of sod piling up. Luckily, I have something called the yard mule. This strange-looking contraption is my home-built electric tractor. I use it for hauling wood and dirt around the yard, and so far it's been great. The yard mule has been working hard out on the farm here for over 6 years, and all I've ever had to do so far is plug it in every couple days. I'm also going to do a complete build video for the yard mule for this channel, but if you want to see a hard copy version, you can find one on chopzone.com. So, will a home-built electric tractor made with an old truck differential and a broken motorcycle handle 2,000 pounds of dirt? No problem. And it drives away without making a sound. After dumping off a few loads of dirt, I realized that this was the right tool for the job. No ruts were being left in the yard, and I had plenty of battery power to run all day long. If we had to move the topsoil with the excavator, it would have taken a lot longer, since I was trucking the dirt down to the bottom of the yard so it would be out of view. This was a 600-foot trip downhill and it took about 16 loads, so for sure the excavator would have left ruts in the yard. I remember hiring someone to use a bobcat to do similar work one year, and it left ruts that were so deep I almost bounced off the seat on my lawn tractor when I was mowing the lawn. It took months to fill in the ruts and let the grass grow back in. One of the many things I wish I thought of ahead of time, but you learn as you go along. Here we are at the bottom of the hill with load number 16 to drop off. I'm so glad this clay is dry or it would be sticking to everything. I promised the yard mule I would give it a few minutes in this video because it works hard around the farm and it really deserves it. I can't even imagine life on the homestead without this beast of burden. 2 hours later and the site is looking good. The clay is so hard it feels like concrete. This is the perfect base to start with to pack down the gravel. Oh yeah, look at that, perfectly level. The ground is sloping downward so it'll drain, and side to side it's perfectly horizontal. This is exactly what we wanted, a perfectly level pit to hold gravel. I checked the level in multiple places and it's perfectly horizontal, and the entire base follows the slope of the yard, so that will allow drainage once I install a weeping tile. Some people choose to install their greenhouses at level ground and then dig down and grow right in the ground. Nothing at all will grow in this hard clay, so I will be using raised beds through the entire greenhouse. Hard clay also doesn't drain very well, so weeping tile will be installed under the raised beds that will draw water away from the greenhouse and down the hill. Okay, let's move on to the next stage. Your work is done here, Mule. You can go rest now. With the exception of placing it right on the ground, a gravel base is probably the most cost-effective foundation for a greenhouse. It allows water to drain through to the base and also allows the greenhouse to float a bit if the frost heaves around. I asked the dump truck driver if he could spread out the gravel for me automatically so I wouldn't have to do any work whatsoever. And of course the answer was, good luck with that, buddy, but I'll do my best. I must say that's not bad at all. Pushing this heavy gravel around with a rake is not fun, so I'm glad it's not just in one giant pile. I also needed 2 full loads to fill this pit, which was actually quite surprising. Once again, the driver does his best to spread out the gravel evenly, and, well, not bad at all. Having it dumped like this probably saved me 3 or 4 days of hard manual labor with a shovel and a rake. What do you know, it's the same guy that was running the excavator. Thanks, buddy, you just saved me a lot of work. The heavy dump truck did leave a few ruts in the yard, but this part is considered an access road, so I can live with that. Alright, let's see what we're up against here. Looks like the pit is filled quite evenly, and the overflow is on the outside, so getting rid of it will be a lot easier. Did I just use the word easy? Sorry about that. No part of homesteading is easy. If it was, it wouldn't be worth anything, right? The goal now is to level the gravel with the top of the original yard, and I have a long way to go. But like all things, just do a little bit at a time, and eventually it will get done. Even my rake is modified. I removed the flimsy wooden handle and welded the metal rake head to a galvanized piece of 6-foot-long fence tubing. 10 years later, it's in perfect condition, and you don't have to wear gloves when you use it because your hands don't get blisters. It took about 2 days to get the gravel to this point, and it was hot both days, so it was quite the slog. Luckily, my home-built shade house was close by. I got to hide from the sun and hydrate, and all these plants were telling me, hey, get me into a greenhouse soon. This greenhouse is actually a portable chicken coop, but we use it to acclimate plants at the beginning of the year. Check out my other video called Build a Portable Chicken Coop if you want to see what this is all about. Once you have your gravel base looking somewhat level, find a long straight board that you can use as a guide and spot check your work every few feet using a level on top. This is one of the wall sections I'm going to use under the greenhouse, and it works great as a leveling base. It's easy to see where you need to add gravel and where you need to take gravel away, so get prepared to use your rake for a few more days. Of course, you're leveling it lengthwise as well, and in my case, I have to maintain a slight slope all the way down so the water drains towards the hill. Add some gravel and take some away as you level. It's a lot of work, but it'll eventually come around. With such a long greenhouse, it's easy to get out of level. Here I'm using 2 straight wall sections so I can visually inspect them at a distance. As you can see, they're perfectly level when you look at them from the end. Okay, all the gravel is leveled. I think this took me about 3 days. Let's see how it looks. Both wall segments check out with the level. Let's see how they look against each other. Yep, that's just about perfect. And it looks like my shed is level too, so that's good news. We're not quite done with gravel yet though. We still need to pack this stuff down so it becomes hard like a concrete base. Gravel will naturally pack down after a few years of sitting, but I don't have that kind of time, so I'm going to use this handy gravel packer. This machine basically slams a metal plate up and down onto the gravel until it's compressed. You also want to wet the area you're going to be packing before you start. It was really dry out here this time of year, so I put a sprinkler on the end of the hose and just moved it around while I was using the gravel packer. Even though this device weighs a few £100, once you get it running, it basically glides along from the vibration and is even self-propelling. Hey, get back here. What do you think you are, some kind of self-driving car? This is a slow-going, boring process, kind of like mowing the lawn in slow motion. You're going to want some kind of hearing protection, preferably something that you can put a podcast on or some music and just get to work. The machine compresses the gravel quite a bit just on the first pass. It's also easy to see where you've been as long as you keep the gravel wet. I'm just making random passes for this video right now, and when I actually got to work, it was much easier to go the full length of the greenhouse, so you did less turning around. It isn't difficult to turn the machine, just more efficient to walk in a straight line, but I wanted to do a section to see how this would work out. After experimenting on the end section here, maybe for 15 minutes, you could really see the difference. It looked like the gravel was packed down a good ½ inch, and it was super hard like concrete. This is super boring, slow work. The packer had to go up and down at least 12 times to cover the entire base, and I think I did 6 or so passes. So rough calculations would say I walked a good mile with this thing. It's important to keep the gravel wet, or you won't be able to see where you've gone already, and it won't pack as well. I walked behind the machine for 2 days, probably 4 to 5 hours per day, and it did pretty good on maybe a quarter tank of gas. The end result is an extremely compact gravel base. It's probably as hard as concrete. You can see the few areas I had to fill in. I was using that wall section and the level just to make sure it was flat. Filled in some gravel, wet it down, and then fixed the areas that were too low. Whatever your plan is for your foundation, take the time and do it right. Everything depends on it. If your greenhouse frame is not sitting straight, it'll be difficult or impossible to get the poly panels in, and you'll probably have leaks and other issues. Oh yeah, almost forgot to mention, you can rent these gravel packers from any place that rents industrial equipment. Okay, it's time to build some walls and get the greenhouse up off the ground. This step is of course optional, but if you plan to have any type of raised bed inside the greenhouse, it's difficult to have any height to it when the curved frame extends all the way to the ground. When I was walking around in the assembled frame, it seemed like you'd be hitting your head on some of the support rails as well, so having that extra height really solved that problem. So what do you need to build walls? A whole bunch of treated 2x6s. I've learnt my lesson using non-treated lumber in my other greenhouse. It lasts maybe 5 years, and then you have to tear it all out and redo it. Treated lumber will cost you probably more than twice as much, but it will last 4 times longer, so it's actually a good deal if you want something to last. I'm just building a standard 3-foot tall wall with 16-inch centers. I like to pre-drill all the holes and make the measurements first, and then start the screws in the holes so everything goes together easily later. One of my rules out here is to never use nails for any construction whatsoever. It's nice to be able to take things apart later for recycle or for the burn pile when it comes time. Okay, here's all the deck screws put in for the top and bottom rails of 2 wall segments. Looks like I have a long way to go. With the size of this greenhouse, I need to make 130 feet worth of wall. As you will find out, building a greenhouse is a lot of repetition. Grouping your operations together makes the work much more efficient. I first measured the position of all the studs, then pre-drilled the holes, then I started the screws, and then everything went together quite easily. The same thing applies to the ribs of the greenhouse, which are all the same and require multiple similar operations. In my design, the walls also doubled as sides for the raised beds, as you will see later in this video. There's nothing critical about building these walls. Mark, drill, and keep on going until the sun goes down. The small section of overhang at the end of the wall is so that two pieces can be joined together. This will also be shown later in the video. Okay, with the wall sections completed, it's now time to lay down the 6x6 treated lumber foundation. Regardless of the extra walls, almost every greenhouse kit that I've seen uses a 6x6 foundation, and it's also recommended by the manufacturer. This type of foundation is a sturdy base for any greenhouse. You can place the 6x6s on flat ground, on gravel, or even concrete. You can also secure the 6x6s to the ground using rebar stakes, which is a must or your greenhouse will be torn away by the next strong wind. Since my foundation is packed gravel, which is almost as hard as concrete, all I need to do is level off the 6x6s by digging off a little bit of the top gravel to make sure they're all parallel to each other. Since I took my time to level the gravel, they look pretty good already. There's a few low spots, but that won't be any problem. Everything also follows the natural grade of the yard, with a slight downhill slope, which was exactly the plan. Okay, I've got my gravel working toolkit ready to go. I also have the stakes because, once again, we have to make a perfectly straight rectangular frame. Marking string that I can pull tight is also important. This frame has to be extremely accurate as the greenhouse needs to sit perfectly on top of it. It's going to be impossible to work the packed gravel with a shovel now, so these small hand tools can be used to scrape down any spots that might be too high. Once again, we need to work with the level and some type of straight edge. I find the wall section works perfectly for this. I haven't done any fine-tuning of the foundation yet, and it's pretty impressive how level it is already. I'd like to take credit for that, but I must admit it was probably the guy running the excavator the first time that made it so level. That's gonna save a lot of work. The total width between the edges of the 6x6s is extremely critical. If you look at the instructions for your greenhouse, the poly needs to extend beyond each end of the 6x6, so you need to be within a 1/4 inch of the total width. Since I'm a bit paranoid with instructions, I didn't want to trust the instructions and then have to completely redo my foundation, so I actually built part of the frame so I could measure the exact width from the outside edges, which for this frame was 118.5 inches. So that will be the magic number to keep in mind when aligning both sides of the walls. Each run of 6x6s needs to maintain that distance from edge to edge, and both runs have to be completely parallel to each other. Aligning your foundation base is probably the most critical part of this job, so take your time and make sure you get it right. Remember how you marked out your site? You're going to be doing the exact same thing here, starting with the two end stakes pounded into the gravel at the desired width. You can then use your large square and the cross-measuring technique to get the other two stakes pounded in, so you have 4 corner posts in a perfect rectangle. Once all 4 corner posts are measured and secured, you can run a tight string from one to the other so you can align your 6x6s along your foundation. When the 6x6s are placed end to end, you can really see if there's any high or low spots. If you're working directly on the ground or in loose gravel, it's pretty easy to level things out now. But if you're working on hard packed gravel, you're going to need to use some hand tools and carefully scrape away any hills that are underneath your 6x6s. Looks like I only had a few 6x6s that were high by maybe an inch. Here's that required 118.5 inches. Everything's looking good so far. There's a few dips and a few hills to deal with, but nothing that bad. I like to stand back and compare the two runs of 6x6s against each other at this angle. Looks like the far 6x6 in the center is just a little bit high, so I'll probably start there by digging off a little bit of gravel. This hard-packed gravel is not easy to work with. I'm glad I only have to shave off a little bit here and there. To avoid taking off too much gravel, I just rolled the 6x6 over once, did a little bit of work, and then rolled it back in place for an alignment check. For any small dips, I just filled it back up with gravel and then did my best to pound it down with a shovel. This was probably the largest dip I had to deal with, and it was only an inch, maybe 2 feet worth, so it was easy to fix. Once I had the 6x6s perfectly aligned on one side, I replaced the string with a much larger rope and then started installing the wall sections. I would have aligned both sides first, but I wanted to get this video done so I could just move on with the build. The wall sections are fastened to the 6x6s using 4-inch deck screws. Here's the overlap section. This will need a little bit of extra work as well. I placed a few deck screws between each of the gaps on the 16-inch centers, and this won't be the only thing holding the wall down to the 6x6s. The 3-foot-long rebar stakes that are going to be rammed into the ground will also be going through the wall section as well as the 6x6s, so the entire base frame, including the walls, will be securely fastened to the ground. Check your alignment as you go along by viewing your work from all angles. To make sure the top wall plate is completely aligned, I use these leftover 2x6 segments to join the two top parts together. Now everything's perfectly straight along the top because that's where the greenhouse frame needs to sit. Well, the sun's going down, so it's time to start putting the tools away. It was another productive day working outside on the homestead. I managed to get both runs of 6x6s installed and the long wall sections built, and everything appears to be nice and straight. The most difficult part of today's work was scraping down the small high spot on the far side of the gravel pad, but after a few hours of working the gravel with the hand tools, both wall segments appear to be perfectly aligned to each other when viewed from the side. There's maybe a half-inch deviation here and there, but that's more than straight enough to put the greenhouse frame up now. Okay, here's the part of the greenhouse build that most people fear the most. There are a lot of small parts and bolts in putting up the frame. Nothing's really difficult, it's just a lot of repetition. The best way to start is to unpack each box and lay out the corresponding parts. The smaller boxes will contain the frame segments, and the large 4x8 boxes will have the poly sheets. You can leave those in the box for now. They're going to go up last after the frame is completed. Look over your instruction manuals and check out other build photos on the internet before you even start. You can get a ton of info just looking at a completed picture. Since these greenhouse kits are modular, the manufacturer will put all parts together in the same box. I found two good sources of information when putting up this greenhouse. First, the supplied instruction manuals, which contained all of the information you would need to actually put up the entire greenhouse, as well as identifying all of the names and numbers of the components you need to build your frame. The second source of information were the videos that the company that made the greenhouse put on their website. Since I'm a visual person, I found the videos to be more useful than the actual instructions, and if I had to choose one, it would definitely be the videos. There were 15 good videos on their website, so I downloaded all of them to my laptop and brought it outside. Matching the steps in the manual with what was shown in the video made building this greenhouse a lot easier. Once you've looked over the installation videos and instruction manuals a few times, separate all the small parts like nuts, bolts, and brackets into separate containers. I used margarine containers and I wrote the name of the part on the side, corresponding to what was shown in the manual. There are a lot of parts here, but you know what? Once you build one rib, the rest will seem easy. You don't need much in the way of tools to do any of this assembly. Basically a socket to hold the nuts, and they're all the same, and a screwdriver bit for your drill. If you have someone helping you install your greenhouse, then each person should have the same set of tools. I'm doing this entire job completely alone, so one drill, one socket, and a lot of patience. Most of these greenhouse kits are basically the same thing, so starting with the two end pieces makes the most sense as they contain the doors. If you ordered the shortest possible greenhouse, you may only have the two end pieces. Before I start building any segment, I lay out all of the required parts according to the manual and the videos. This company, Planta, labeled everything quite nicely and even included arrows to show which way the part would be installed, and that really helped. If this is your first time installing anything mechanical or looking at a diagram, the videos are going to be your best friend, so make sure you download them and look them over a few times. Here I'm starting with the arches, the basic curved segments that define the shape and overall width of the greenhouse. Depending on how many segments you have, there may be quite a few of these parts. I like to lay all similar parts out on the lawn, so when I'm working like an assembly line, everything is right there ready to go. Keep track of the numbers and remember which way the arrow is pointing. It's easy to install things upside down, and trust me, you're going to do that a few times. This is pretty much what you're going to be doing for the next couple of days. Hold the nut, turn the bolt, and then repeat the process until all of those hundreds of bolts are in place. Success! I've put something together. Once I had all of the parts laid out according to the instruction manual, I pretty much used only the videos to do the rest of the installation. They made a lot more sense. The black and white diagrams were decent, but sometimes it's difficult to determine which way a part's facing. By laying my parts out exactly the way they were shown in the video, it made the build process go a lot smoother. All of the frame components are lightweight galvanized channels. There's a front side, a back side, and often a direction of installation as indicated by the arrows. Okay, I've laid out the topmost segment of one of the end walls, and there's a few more pieces to go. Let's go check out the manual one more time. Looks like there's a few more small lower segments to install. Not quite sure which way they face, so let's go have a look at the video. Okay, that makes sense. Channels up and the brackets over the top. These L brackets help fasten the greenhouse down to the wooden foundation. This kit also included legs to install directly in the ground, but I will not be using those. Okay, 4 bolts on the top. Let's see how we're doing. Hey, wait, something doesn't look right. There's no hole for the 4th bolt. I wanted to point this out because there sometimes are manufacturing problems. And it's the same thing on this side as well. Rather than moving ahead and just thinking, I don't know how to read instructions, I decided to add the extra hole, which wasn't really a big deal. There were a few other places that had missing holes, but again, it was no big deal to add them. They probably got missed at the factory. I ended up removing this door threshold component in my final design anyhow since I raised the greenhouse up, but for now I needed it so I could get the total width of the frame. Here is one completed end wall that looks exactly like what's shown in the video. Now that I've done one, I don't even have to look at the instructions again. I can just duplicate what I've already done. If you're building a long greenhouse, you'll find that most of this is repetition. The first part will take you 2 hours, and every one following will take you half an hour. Here are the 2 completed end walls with the included door frames. Both parts are the same and they look exactly like what's shown in the manual and the instruction videos. Everything from here will be rib sections and horizontal bars to hold them all together. The overall length of your greenhouse will determine how many rib sections you need to make. Now that I had a general idea how things were going together, all I needed was the instruction video in order to make one of the ribs, which is basically a rounded arch with a triangular structure inside to give it strength. In construction, a triangle is the strongest known shape, and you can see here that this arch is made up of triangles, which is why it can carry a snow load. We live in northern Canada and get a lot of snow, and I can assure you this frame can take it. Here is one completed end section. Every greenhouse kit will usually have 2 of these, and I recommend you build at least one before you start laying out your foundation, as you can use this as a guide for proper width. I decided to add the wall for height after I built this part. It just didn't seem tall enough, and since we can't grow in the clay, I knew I'd be installing a raised bed. The problem with installing a tall raised bed in a curved greenhouse is that it has to be pushed away from the outer wall, which then reduces the space in between the beds in the middle. The trusses that form the triangle sections make this even worse, and it looked like it would be easy to hit your head on one of the bars when moving around in the greenhouse. The extra height definitely solved that problem. If you were going to install your greenhouse on a 6x6 and just plant right in the ground, you'd probably have no problem whatsoever. Okay, here is the bulk of the work I have to do on my frame. 7 extension systems and a whole lot of small nuts and bolts. I know this looks daunting, but by the time you're done, you won't even be thinking about it. You'll be building this thing with your eyes closed. It's all repetition from here, so if you have a friend that owes you some time, tell them to get over here with the drill and a screwdriver. Me, I'm working alone. I find this really relaxing and I actually enjoyed building this greenhouse. One extension kit includes 2 ribs and the horizontal bars that hold them together. It's basically the same as the front and end sections minus the door frame. You are going to be doing a lot of the same things over and over, so try to find the most comfortable workspace, and try to keep all of the parts in one place so you're more efficient. Since I only had to refer to the instructions once, it only took a day to build all of these ribs. Sure, I installed the odd piece upside down, but that's easy enough to fix. It's really satisfying to get to this stage in the build because it really looks like you have something. Now you just need to get it on your foundation and get the poly installed. I actually built this much of the frame before I even started the foundation. I wanted to see how tall this would be and actually take measurements from the frame before I started the foundation. Installing the frame on the walls is easy. Just drop them in place and then use wood screws on the L brackets to hold them to the top of the wall. Each segment will then be fastened to the next using these horizontal bars, and that determines the overall length of your greenhouse. At this stage of the build, you really want to have your rebar stakes rammed through the wall and the 6x6s into the ground at least 3 feet. Later during the build, I also added bracing as there's nothing to stop the walls from falling over from side to side, as there's no front or back wall for support yet. Another consideration if you plan on adding height to your greenhouse is the height of the door that's supplied with your kit. Obviously this won't work as there's a bar right across the front of the door. Later this will be removed and a custom lower door will have to be made, and you can see this later in the video. Starting with the front door segment fastened right to the edges of the walls, I then installed the horizontal bars that joined the segments together. Everything's looking nice and straight. If there were any inconsistencies in the foundation, you would certainly see it amplified through the horizontal members in your frame. Alignment problems really become an issue when you start installing the poly panels. Tolerance is pretty tight between the panels, so if you have any obvious alignment problems, this is the time you want to fix them. I now have all the extension segments installed and only 3 more runs of horizontal bars to complete the entire frame. This thing looks huge. Well, at 550 square feet, it is pretty big. It's about half the size of the house. I'm really glad I added the walls for extra height. This made working the raised bed so much easier. You don't even have to bend over because they're 3 feet high. Raising the greenhouse up enough so that the truss sections won't be in the way also makes it easy to add a workbench. Another day is coming to an end, and I have a complete frame sitting on top the walls now. With poly covering and window installations to go, I would say we are about halfway done, and that's not bad at all. Alignment of the frame is looking really good at all angles, so installing the poly should be quite easy. Walking through the greenhouse, I'm already getting ideas for hanging plants, drip lines, lights, maybe even a speaker system. We have decided that the south side of the greenhouse will have a 50-foot raised bed, and the other side will be the working area, with workbenches and a heated table. Before the poly goes up, I think I'll work on the window frames next. When I was researching greenhouse kits, a lot of builders posted their photos on the website and the forum, and one thing I noticed was the lack of windows. I found this strange because even out here with only 3 months of summer, it would be impossible to operate a greenhouse properly without a lot of ventilation at the top. Someone suggested that the windows were just too complex to build, but since I wanted 8 of them, I guess I was going to find out. Just like before, I looked over the manual and then watched the videos a few times in a row until I understood what I was attempting to build. Yes, there are a lot of parts to the window, and it is probably the most complicated part of the frame, but like everything else, just take your time, look over the instructions until you understand what you're doing, and go for it. The window frame is basically a rectangle with curved edges so that it conforms to the top part of your greenhouse. Like the rest of the frame, it's made up of triangles for strength, although I must say it's probably a bit overkill to have both pieces crossing like this. One would have been plenty. One thing I would recommend to the manufacturer if you're listening, sell these windows completed. You'll sell a lot more windows and the shipping box really won't be that big. And to all builders out there, don't skimp on windows. Your greenhouse will fail without them. It took an entire day to build all 8 window frames, but it was worth it. Even with snow still on the ground, we've had to open all 8 windows during the day, so I can't imagine running a greenhouse without proper ventilation. Here is a completed window with the hinges and the poly installed. The poly is cut from the actual greenhouse, and I'll show this later. If you plan to build your greenhouse on a wall, you won't be able to reach your windows from the ground, so you'll need a ladder or some type of modification. I came up with a system that works well, and I'll show that at the end of this video. The last part of the framing consists of the front and rear door and the 2 little windows above the door. The doors are easy to assemble. They're just basic rectangles with 2 cross members, top and bottom, that form a bunch of triangles. One side of the door has a plate that will hold the latching hardware, and the other side will have the 2 hinges. The poly for the doors comes from one of the full-size sheets, and it's just cut out to fit the door frame. Of course, one problem with a raised greenhouse is that your door is going to be too short. And you also have to remove the piece that's across the bottom of the door because it's now 3 feet off the ground. I will show you how I dealt with that later, but I just wanted to show the fully completed door and the little window above it installed. I didn't really have a plan for the lower part of the doors just yet. I figured once I built the end walls, I'll come up with something. Here's a shot of the end wall with all the poly installed. Installing the poly is virtually the same throughout the entire greenhouse using bolts and large washers, and I will show the entire process in the next few steps. Since it's impossible to use the doors at this point, I just wired them shut. I also don't have the door handles installed because I'm not quite sure what I'm doing about the lower section just yet. Raised off the ground like this, the front section really isn't that sturdy, so I added a 2x6 across the width and then fastened the door frame to it so it wouldn't be damaged if we had a heavy wind. Alright, it's time to cover your greenhouse. Here are all the poly panels after removing them from the packing boxes. These corrugated plastic sheets are rated in thickness in millimeters and by how much sun they let pass through. The polycarbonate sheets that came with this greenhouse are called 6mm double wall. With this thickness of sheet and this type of frame, this greenhouse is rated for 65 miles per hour of wind or 3 feet worth of snow on the top. I know we've seen higher winds than that already, and there's no way snow sits on the top, so we're all good. This double-sided tape will be used to secure some of the frame members directly to the poly, and the clear tape will be used to seal the bottom edges so moisture and bugs can't crawl into the channels. The poly has one side that needs to be exposed to the sun as it has a UV-resistant coating. Unfortunately, once you remove the protective sheets, you have no way to tell which side that was. To get around this, I recommend you take a Sharpie and mark the side that has the poly protection, so when you're installing it, you won't get it in backwards. Once you mark the UV side, you can then remove the protective covering. These are the flat pieces that join the poly on the end and are installed horizontally along the greenhouse to join one piece of poly to the next. They align with the horizontal members that join the segments together and then are held in place with bolts and washers. These pre-drilled holes line up with the holes that are already in the frame members. Some of these pieces also go at the ends of the greenhouse. They're a little longer and they have an arrow to show direction, so put those in a different pile. The topmost pieces of poly are cut halfway through so they can bend around the point on the greenhouse, but still remain as one continuous sheet. If you've ever worked with drywall, you'll find this to be pretty much the same thing. You need a sharp knife and a straight edge so you can draw your knife along it, then you basically push down until it snaps. To bend the sheet without completely snapping it in half, mark a line halfway across and then score a line with your knife using the straight edge as a guide. You don't have to cut right into the board, just a good score line so that it snaps along that line. Once you've scored a line across the halfway mark on the board, place it across a sharp edge like a 2x4 so when you push down on it, it breaks right along the line. With a nice sharp blade, it doesn't take much effort at all to snap the board once you push along the edge. The poly will break right along the cut line, but the bottom side will remain intact. And this corner is what goes at the very top of your greenhouse. In the instructions, it tells you to put tape along all edges of open poly, just like this. The idea is that it keeps moisture out of the channels as well as stopping bugs from crawling in there. I can tell you that no matter how much tape you use, it won't stop condensation from forming inside the board, but it will certainly keep the bugs out. If you've taken your poly out of the box, I recommend you tape all the edges right away because bugs will start crawling in there the minute they find it. Each piece of the topmost poly that you snapped in half is going to have one of these horizontal members taped to the end, so you need 2 of them for each piece. The double-sided tape has a sticky side and a side with a protective covering. Leave that on for now. Cut the required length of tape and stick it to one side of the member as shown here. Once you pull the protective cover off the sticky side of that tape, it will stick to anything it touches. It can be a bit tricky to align this piece to the poly on your first try, but here's a simple trick that'll get it done right every time. With the protective coating still on the tape, butt the edge up against the end of the poly just like this. With the edge pushed right up against the poly, make sure it's centered, and then carefully roll the entire piece back along its edge, making sure it doesn't move from its position. Now it'll be aligned right to the edge when you roll it back down. Now push down on the metal piece and carefully remove the protective covering on the sticky side of the tape. It's a lot easier to have someone else pull that strip off, but if you're careful, you can do it yourself. I did all of these like this and it worked out perfectly. Now just carefully roll it back down and the tape will grip exactly where it's supposed to. Now press firmly along the entire edge to seal the tape and you're done. This piece of poly is now sealed from the elements. The other side doesn't need tape because it overhangs the next piece of poly, acting like a shingle, so water can't get underneath it. Slide the poly sheet up over the greenhouse until it rests on the top where you made the bend. The correct position is between 2 of the ribs, and so that the metal piece is facing upward. Each of the horizontal members that hold the ribs together will have holes drilled that will match up with the piece that is now taped to the poly. Install the nuts and bolts as per the instructions on each side. If you are working alone and it's windy, you're going to need some type of clamp to hold one side while you bolt the other side. Continue to cut and bend each piece of poly, glue on the horizontal member, and then get them fastened to your ribs. You won't want to tighten the nuts completely at this point, since the next piece of poly is going to slide up underneath the horizontal member, but certainly get it on enough so that it's not going to come off in a wind. Wind and weather is always a problem at this point in the build, since you haven't yet installed the strapping or other components that give this greenhouse its maximum strength from weather events. At this point, you can check your alignment by climbing up and looking down the ridge to see if everything is completely straight. If there are any obvious deviations in your foundation, something isn't going to look right from this vantage point. So far, it looks like I'm doing good. Everything is in a nice straight line. Another test of your accuracy is to look down the length of all of these top horizontal pieces to see if they all line up. And yep, they're looking good too. In this design, the two end pieces of poly are a little longer than the other ones in the middle as they overhang the front and end walls of the greenhouse. So the horizontal members that are going to be glued on are also slightly longer than the other ones. The end pieces of poly are pressed into this rubber weather stripping, which is why you need to build the front and rear walls first before you put these last two pieces in. Slide the weather stripping along the edges of the poly on the front and rear walls as shown here. There wasn't a clear description on how to fasten the very bottom, so I ended up just using a deck screw and screwing it right to my wall section to hold it in place. You are now ready to start installing the main pieces of poly on the sides of the greenhouse. The good news is there's no cutting to do. The not so good news is that you're going to find out if there's any problems with your foundation. If your foundation isn't straight, these pieces of poly are not going to line up with each other. Installation is simple. Start by placing the top of the poly sheet up underneath the horizontal member as shown here. If you are working alone, you're going to need some way to hold the bottom of the sheet. I found by placing a 2x4 like this worked perfectly. Once the top of the poly is placed under the horizontal member, you want the edge to be exactly in the center of a rib like this. The first few sheets will always look straight, but if your foundation is off, by the time you hit the middle, you're going to find it hard to get the poly sheets aligned directly in the center of the rib. The instruction manual said I'd need 2 people for this part of the job, and well, I just couldn't accept that, so I came up with another trick. Just wedge a 2x4 up against the head of the bolt, go around to the other side, and then install the nut. The 2x4 held the bolt with enough friction so I could turn down the nut. You don't have to put these on very tight, so this worked out great. This is another repetitive job, but an easy one. Keep on going until all of the sheets on one side of your greenhouse are installed. A few hours later, I had 11 sheets installed, and so far alignment was perfect, so I guess my foundation is good. It's highly motivating to see the greenhouse get this far, so I think I'll put in a longer day. I'm still a bit worried about wind hitting it when it's like this. I almost forgot to show you how the frame is being held down to the top of the wall or your foundation. It's simply 2 screws put right through the L bracket to hold it down to the top of whatever you're using as a base. I put about half of these in before I remembered my rule. Phillips heads have no business in construction. So I took them all out and put them where they belong in the garbage can and then put in proper Robertson head deck screws. Once I had one side completely covered in poly, I also moved my working area inside. I sure like the extra height in here. I'm really glad I decided to use that 3-foot tall wall. Looks like we're climbing over another milestone. All of the poly is installed and this thing looks like a greenhouse now. It's hard to believe that this started off as a few flat boxes on the back of a truck. Placing it on top of that wall made all the difference. We've been using it for a few years now, and when we go to build a second one, I'm going to do it exactly the same as this one. It's really been working out. I think the only thing I'd do different now is modify the actual door that came with the greenhouse to extend all the way down, rather than building a second smaller door. Of course, doing it that way would require some welding and an extra sheet of poly to make up the difference. The last parts to install on the frame are the ridge cap at the top and the metal bands that go between all of the poly sheets to hold them down and secure them from the elements. These 2 parts are simple, but without them your greenhouse would not be able to withstand any amount of wind or snow loading. The ridge cap seals all of the poly at the top, and the metal bands press down on the poly and the entire greenhouse frame, creating a much stronger structure. The metal bands are fastened to the foundation on either side of the greenhouse, so if your greenhouse frame is resting directly on a 6x6, the bands will be fastened directly to it. In my case, I will have to fasten the bands to the top of the extension wall, so I have to actually get the siding on before the bands can be installed. The height of my wall was calculated so that I could cut a standard piece of metal roofing in half and then mount it as shown here. The metal siding is tucked underneath the poly, so any rain will shed away from the building and not into the greenhouse. This overhang also leaves the option to install rain gutters in case we want to capture some of that rainwater and store it for later. In order to install the metal siding around the entire perimeter of the greenhouse, I finally had to finish both end walls. And here you can see the obvious problem that happens when you install a greenhouse on top of a wall. The supply door is going to be much too short. I wanted to get this build finished so we could start using the greenhouse, so I took the easy route and just made a sub-door underneath the original door. If I had more time, I would actually modify the original door by welding a section on the bottom so it continued all the way to the base. These are the 4-foot rebar stakes that I'm using to secure the foundation to the ground. I would have installed these before any of the frame sections were put on top the wall, but I had to do repairs to my welder after making only a few. And since the weather forecast did not call for any wind, I just relied on the bracing and the few I had installed already. I wouldn't recommend you do this. Install all of your stakes first. Here you can see the full height of each stake. It sure took a lot of smashing with the sledgehammer to get them all the way into the clay. The stakes are pounded through the top plate of the wall and the 6x6 on a slight angle. Just like tent pegs, they work better placed on an angle. Plus I needed to do that in order to clear the top of the wall plate. I drilled the first hole and then marked it on the drill bit so I wouldn't have to dig into the clay each time with the bit, as that would make it dull. Going through that packed gravel and all of that hard, dry clay took a lot of effort. To make the job a little easier, I took the grinder disc and shaved a point into the bottom of each stake, and that did seem to help. Only 16 more to go. Okay, let's get back to the final parts of the frame build. Here we have the roof ridge. These run along the top of the greenhouse where the poly has been split. These all bolt together to form one continuously long ridge piece, and the strapping is actually placed between each bolt. I've seen a lot of suggestions on how to install this part. None of them really work well with one person, so I came up with my own system. What I did is bolt one piece to the next and carefully push it along the ridge of the greenhouse. This system worked well and had the added benefit that it automatically aligned the ridge piece along the top. Another thing to consider when creating a wall for a greenhouse is making sure that the ribs line up with the studs in the wall. This way you can modify your straps to actually bolt to the wall studs. And this was necessary because they're not long enough to go all the way down the wall, as they were only supplied to be used with 6x6 foundations. I also marked the receiving straps for trimming. This way they wouldn't have to clear one of the ridges in the siding. I didn't consider a lot of these small modifications when I first decided to put the greenhouse on top of a wall, so hopefully this video will give you some ideas for your own modifications. I also used a hammer and a wood screw to pre-punch little holes in the receiving strap so that when I went outside to install it, it would be easy. I'm using standard roofing screws for this, so they'll drive right through the receiving straps and the siding into the wall studs. Align the top cap so that the two bolts sticking out are between the rib like this. The metal band that holds down the poly will then run down the side and get captured by this other piece that was just installed. These two parts are installed so they are just out of reach of the metal band's total length. That way the bolt can be tightened, which will pull it down towards the ribs. This is the bolt that will tighten down the band towards the piece that captures it. At the ends of all of these pieces is an L-shaped part with a hole through it. This is where the bolt will go on both sides of the greenhouse. A small weight on a string will help you get that band up and around the greenhouse. Use wood so you don't scratch your poly. Once you have the band over the greenhouse, install one bolt and leave it with about 2 inches of slack. Make sure the band is placed between the two bolts on the ridge cap. You can then move to the other side and install the other bolt, giving it about 2 inches of slack. At this point, attempt to keep the band in the center, go to each side and adjust it as necessary. You want this band to be installed right at the gap between the two pieces of poly. This becomes a weather seal. When you are doing the final tightening of the bolt, try to do it the same on both sides. It makes it easier to adjust later. Continue installing all the other straps until you are completely done. My greenhouse has 16 pieces of poly, so there are 17 total straps. Your instruction manual will tell you how tight to make the bolts, but a simple rule is, if the L shape is starting to bend upwards, that's probably too tight. I also noticed that these things do settle a bit. I had to tighten them down once more after about 2 months in the sun. I also check the straps after a winter. Once in a while the frost moves around and 1 or 2 need tightening. At this point, your basic greenhouse frame is now completed. With all the straps tightened down, it is as strong as it will ever be, ready to take on any weather. As you do the final tightening of the strap bolts, take a look inside to make sure that ridge cap is staying in the center where it should be. So far, all 55 feet of this greenhouse is looking good. I'm glad I have doors on both ends. This is quite the walk. There's only one thing left to do in order to make this into a fully functional greenhouse. Install all of those windows. And here are all 8 of them, partially assembled. I chose 8 windows so one would be positioned about every third piece of poly. There's also a window opposing it on the other side. This so far has seemed to work quite well. As shown earlier, the windows are small but they contain quite a few parts. There's trim, frame parts, hinges, latches, and quite a few small bolts. I've already built the base frames for all 8 windows, but there's still quite a bit to do. All of these weather strips have to be installed, but that can't be done until you install the poly, and that's going to be actually cut from the place on the greenhouse where you want to install your window. Cutting the section out is easy though, you can use the frame members as a guide. Okay, you're going to need a ladder and the same sharp knife you used to cut the poly earlier. This time you are going to have to cut right through, so make sure that's a fresh blade. Don't forget to mark one side of that poly with tape or a marker. Remember, one side is UV rated and one side isn't. Run the knife along the edge of the metal as a guide. You will probably have to make multiple cuts in order to get right through the poly, so take your time and make sure the knife is running right along the edge of the frame. No, I'm not going to try doing this while I'm holding the camera. You're just going to have to trust me here. Okay, here's the piece after cutting it. I think I ran the knife at least 5 times through each cut to make it go completely through. If you haven't done so already, remember to mark the UV side of that poly. I usually use a black dot to indicate which side faces the sun, but in this case I marked it from the inside, so I have to flip the piece over. This probably isn't such a big deal for the windows, but for the main poly panels you certainly don't want them in backwards, or your greenhouse will have no UV protection on the inside. Continuing along with the instructions, it told me to bolt the poly on the outside of the window and then trim off the excess as shown here. The poly is placed on the outside curve, and that is the UV side facing the sun. There sure are a lot of steps in building the windows. It probably took as long to build the 8 windows completely as it did to build all the ribs. But like all parts of this greenhouse, once you build one, the rest of them will be easy. I did get snagged up a little bit at this stage, then I realized that there were 2 holes missing from the factory again. There was a hole for the outer bolt here, but nothing for the inside one. It was also the same on the other side for all of these longer trim pieces, so I just marked the holes that needed to be drilled. No big deal, that's what my drill is for. The hole was missing on the weather stripping and not the frame member, so I just used the original hole as a guide and added the new one. I had to add 4 holes for each window, so it did add a little bit of extra time. Because of the extra wall height, these windows are completely out of reach now, so I designed my own latching system, which I will show later on. The original system has this rod that locks up against the frame member so the wind can't blow the door open. There is also a chain and another rod to hold the door open, but I'm not going to use any of these parts in my design. Okay, here are all the windows completely installed. I have 4 on one side and 4 on the other side. There are also windows above the doors at each end of the greenhouse, and so far ventilation is really good. I staggered the windows as shown here, so if there was a cross breeze, it wouldn't just blow straight through one window and out the other. If your greenhouse was built directly on a 6x6 foundation, then at this point you're done. Since I went for a tall greenhouse, I still have a few more things to do, like the bottom section of the doors, raised beds, and a workbench. Making the lower doors was simple. It's just a simple 2x4 frame with more of the siding bolted to it. Just like the rest of the wall framing, I used treated lumber. With all of the water that's going to be spraying around here, standard lumber probably wouldn't hold up very well. To fasten the doors to the greenhouse walls, we found some used hinges at our recycle store and just bolted them on here, just like hanging a regular door. Alright, let's get the doors installed so I can clean up this disaster zone. Looks like a construction site, not a greenhouse. Okay, here are the doors installed on the hinges. I left a 1/4 inch gap between the wall and the door in case anything shifted, and left the siding overhanging at the bottom so that it would create a stop for the door. I was also going to attach the lower door to the main door, but having them separate seems to have a few advantages so far. The last thing I did to the door is install this simple locking pin system. It locks the door closed in the greenhouse, but also stops it from flopping around in the breeze during a wind. Since we do have a lot of wind out here, I've been using this same system on all of my shed doors, and it's working great. You can leave your door open, then just push the pin into the ground so the door doesn't swing back on you in a wind. Oh yeah, did I mention this door is wide enough for all of our wheelbarrows and the small wagon to go through it too. For the main door, I used some of the spare window parts to make this simple hook and chain system to hold the door open. I don't remember seeing anything in the manual about holding the door open, but this system is easy to build and it works really good. The door latching hardware that came with the kit is also quite well made. It was easy to install with a few bolts, and it does hold the door nice and secure. So that completes my top and bottom door installations. Now I can move on to building the raised bed. This is basically another wall that matches the original one to create a 50-foot long box that will be filled with soil. Once again, treated lumber of course. This wall section will be built exactly the same way as the other sections, using treated 2x6s and 16-inch centers. The only difference here is that the wall is a bit taller to compensate for the 6x6 that is on the other side. The top of the inner wall needs to be the same height as the outer wall, so the raised bed is even. I built the wall sections and then just laid them on the ground as a mock-up so I could see what a 30-inch wide raised bed would look like, and it certainly looks big enough. Since the growing soil will be placed right on top of the hard-packed gravel, it doesn't really have any draining capacity. And although it's unlikely that the raised bed could ever be overfilled, I didn't want to take any chances, so I'm going to install a 4-inch weeping tile that will take any water that pools underneath outside the greenhouse. This is basically called a French drain, and any water that ends up in the tube will flow downhill because the natural slope of the yard is already slightly graded downwards. Because of that, I only need to trench down 4 inches to get the tube under the gravel, and everything else is already done. This 4-inch diameter PVC tubing has a cloth covering, which is designed to stop anything from clogging the small holes that are cut on the inside of the tube for water to get into. I trenched out the gravel using the standard garden hoe, and wow, it took a lot longer than I thought. That stuff is so hard packed. Hey look, only 40 more feet to go. 2 days later, after sweating it out in the 120-degree weather, I got the trench done. Well, it's not perfectly straight, but really all that counts is the slight downward slope, and it looks like I have that the entire length. Any excess moisture that makes it under the raised bed will end up in the weeping tile and then flow all the way outside the greenhouse, where it'll then run off on the hill like all of the other water that drains in our yard. Just to make sure it works, I filled the tube with some water from the hose and it did make it out the other end. With the weeping tile covered back up, it's time to make the inner walls for the raised beds. I'm using the same style steel roofing for the inside wall, but this time without the painted color. This silver stuff is actually cheaper, and since it's all going to be buried by the soil, there's no point being fancy. There will be quite a bit of pressure from the soil against the walls, so extra bracing will also be added to the raised beds. Okay, here's one full length of the raised bed wall completed. That is going to be a huge amount of growing space. It's also 3 feet wide and 3 feet deep, so you could plant just about anything in there. With the outer raised bed wall complete, it's now time to install the inner wall and get it leveled with the outer wall. I decided on a 30-inch interior size. That seemed to be easy to reach across and still left lots of room in the center of the greenhouse for a wheelbarrow or a wagon. Leveling this wall is quite a bit easier since the gravel pad is already mostly flat. High spots were scraped down and any low spots were just filled with gravel. I made up a few more spikes by welding washers onto some 3/4-inch rebar, and these will be placed about every 4 feet in order to secure the raised bed wall to the ground. These 2x4s are installed to hold the width as I work on the lower section of the wall. In order to stop the inner section of the raised bed wall from bowing outwards under the weight of the soil, I had to install these cross bracings about every 8 feet. These are screwed into the vertical studs on each side using 8-inch lag screws, which is why it was important to make sure the vertical studs on each side lined up with each other. Okay, with all of the bracing and interior walls done on the raised beds, next up is a very simple job: trucking in 400 cubic feet of soil using a shovel and a wheelbarrow. Yeah, simple doesn't always mean easy. The closest I could get that topsoil was 200 feet from the greenhouse, and it's through the tall grass as well, so this was quite the chore. This temporary ramp sure made it easier to get the wheelbarrow in and out of here though. It took about 3 days to get half of it done, plus I landscaped the outside of the greenhouse and planted clover. But like all things out here on the homestead, if it's worth doing, it's probably going to be a lot of work. But look on the bright side. You're saving yourself $30 a month, not needing a gym membership. I can't remember if this was 1 or 2 full dump truck loads worth of topsoil, but I can tell you I used at least half of it to fill the raised beds in the greenhouse. And look at this, naturally occurring grapes growing right out of the compost pile. These are going to make a great snack. Time for a break. With the raised beds filled, it's time to build a workbench. The top will be used for container growing, and underneath will be storage for pots and other gardening utilities. Once again, everything will be made from treated lumber. This time 2x4s and these 1x6 fence boards. I wonder which building has more lumber in it now, the greenhouse or the house. These will make the workbench tops. They're about 3 feet wide and 8 feet long. So with the raised bed and the workbench, that leaves a little over 3 feet of walking space between both. Like all my construction, everything is done with screws instead of nails, just in case I need to make modifications, or if I live long enough to need to replace any of these overbuilt parts. All of this treated lumber construction will probably last 40 years, so I'm not too worried about it. The workbench frame is simple. There's a top, a bottom, and then legs holding both together. I built 32 feet worth of workbench, which left some space on each side. On one side will be another 8-foot heated table of a different design, and on the other side we may want to put a hot tub in there someday. There is also a 6-inch space left under the bottom shelf. By the time I had the tops done on the workbench, plants were already coming out of the raised bed. The greenhouse was looking good and it was sure retaining heat at night. During the day, we had all 8 windows open and both doors at each end, so I'm really glad I took the time to install all 8 windows. We also eventually added a large fan at one of the ends, and we'll probably put one at the other end as well, just to move the air around on a still day. The final thing to be built in the greenhouse was a heated propagation and seeding table. This is another 8-foot table with similar construction to the workbench, but with a much heavier top, as it will contain hundreds of pounds of sand. Within that sand will be heated coils, so that the entire volume of sand works like one big radiator, evenly heating whatever's placed on top of it. The sand will also be wet, so it'll really weigh a lot, which is why the top section of this bench is made with such large lumber. That is a 2x12 frame with a 2x4 floor. The top is built so that it is 8 inches below the frame, so it can contain the volume of sand, and the underside of the bench is built like all the others for storage. All of the tops and bottom use the same 1x6 treated lumber fence boards. For added insulation, we added 2 inches of rigid foam on the top of the sand bed. That still left 6 inches of volume for all of the sand. You can buy these bags of sand at any hardware store or gardening center, and it's called sandbox sand. It's really fine and holds water well, so it's really good as a propagating table base. I think we used about 16 bags of this sand to completely fill up the table. To make a heated propagation table, you need 3 components. There is a controller which can switch the power to your heating coil on and off based on the temperature that it gets from a sensor. These are actually designed for growing mats, so you can find them online or at any gardening store. The controller plugs into any standard AC outlet and basically switches its own AC on and off to the coil that will be plugged into it. The controller comes with this small sensor that goes in the soil. That's how it knows when to turn the heating coil on or off. The heating coil is also a standard gardening item. It is designed to be buried in the soil and plug into the controller. You can usually buy all these items as a kit, but if you're buying them separately, the only thing to look out for is to ensure that your controller can handle the amount of watts that your coil is going to use. The heating coil is buried halfway into the sand. So since our table has 6 inches of sand, the heating coil is at the 3-inch mark. Run it back and forth on your heating table until you've used up all of the coil. Everything is waterproof except for the controller, so I mounted it to this simple stand and then just dropped a plastic container over top of it to keep the water off. This worked well and made it easy to just remove the container when you wanted to make adjustments to your temperature. The table bed was wrapped in this black plastic before it was filled with the sand. This way the water can't get through the table and soak anything on the lower shelf. For even heat convection through the sand, wet the entire volume using a garden sprayer like this. This only has to be done every few days, depending on the amount of sun hitting your greenhouse. When working out the dimensions for your heated table, consider the size of your growing trays. We calculated the dimensions for our table for 12 growing trays. The heated probe that comes with your controller can be placed directly in the sand or in one of the growing trays. Once the probe is installed in the soil and the power is turned on, all you have to do is set the temperature and everything else will be automatic. With the addition of row covers placed over top the growing trays, you can really extend your growing season and get a jump start on all your small plants. So far, this design has proven to work very well. We may actually build a second heated table on the other side of the greenhouse where I left some space. Okay, here's one last modification I made to deal with the fact that the windows were too high up to reach. This window lifter and latch was just a prototype I made to see how it would work, but it worked so well that I made 8 more and we've been using it now for 3 years. The rounded section rests on the greenhouse frame to keep the window open, and the little piece of tubing that extends beyond that can be manipulated from ground level using a hollow pole like a broom handle. It's really easy to open and close all of the doors from ground level, and you won't need to climb a ladder. I also found that this modification holds the windows open a little further than the system that came with the greenhouse. It also seems a lot more solid during a wind when the windows are open. The dimensions of this window latch are pretty basic. You can probably figure it out from the video and nothing is really critical. But if you do actually want a dimension drawing, I will post one on the chopzone.com forum soon. Even if I could reach the windows, I think I'd still prefer this system. It just seems to be really robust. We are now into year 3 with our greenhouse, and it's been performing perfectly. I really enjoyed building the greenhouse and can highly recommend it to anyone. I hope this video helps inspire you to build your own greenhouse.